So today we're going to be talking about logarithmic functions. Logarithms are the inverse of exponential functions. Meet Logger Dan. Logger Dan is going to help solve all of our log problems. He has lots of muscles and is a good-looking man, which means Logger Dan has good DNA. I know you're all probably wondering how this is going to help solve our math problems, but I promise that there's a point. So let's look at the following function to see how Logger Dan has good DNA solves our problems. So this is going to be Dan, and this is going to be DNA. So you can see here that our D is being taken in by this 5, 25 is being represented by A, and X is being represented by N. We have this function right here, log base 5 of 25 is equal to x. This is our log function. We are going to change this to be 5 to the x power equals 25, and these two things represent the same thing. We did this by taking our 5, which is our D, our 25, which is our A, our x, which is our N, and making it DNA, because our 5 is here, our N is here, and our 25 is here. Evaluating logarithms. Set the expression equal to y. Rewrite in exponent form. Step 3, get the bases to be the same on both sides. Step 4, corresponding exponents of like bases are equal. Also, you could ask yourself which power the bases need to attain the argument. Evaluate the following. So our step 1 is set this equal to x. This is going to be our D, this is going to be our A, this is our N. To make this DNA, we have 4 to the x equals 64, which is our DNA. We want to get the same base. We want to get 64 to be the same base as we have over here, which is 4, which gives us 4 to the x power is equal to 4 to the third power, which simply just makes x equal to 3. Now let's try the next one. Same process. Set equal to x, D, A, N becomes D, N, A. Now we want the same base. So this becomes 5 to the x equals 5 squared, which now simply is just x equals 2. Let's look at the next one. Set it equal to x, D, A, N comes 1/2 to the x equals 16. This one's a little bit tricky because we need to think about negative exponents. So this is going to become 2 to the negative 1 raised to the x is equal to, let's get a common base of 2 over here, which is 2 to the 4th. Now when we have a power raised to a power, we know we just multiply those powers. So we get 2 to the negative x equals 2 to the 4th. And we get as our final answer, negative x equals 4, which we divide by negative 1, and get x equals 4. Please pause your video here and try the rest of these problems on your own. The next slide will be the answers to these problems. If you have any questions, please ask in class. These are the answers to the problems you should have done on your own. Pause the video and take a moment to check. Common logarithms. Logs whose base is 10. No base means base 10. So when there is no base underneath a log, it's implied that it's base 10. These two things are the same. Natural logarithm. Logs whose base is e. ln of x is equal to log base e of x. ln represents the natural log. ln x means base of e. Evaluate each expression. This is the same thing as log base 10 of 100. And when we evaluate it, we know we're setting it equal to x. We label our DAN and make it DNA. Get our common base and get x is equal to 2. Same thing here. We set this equal to x, and we know this is the same thing as log base e of e is equal to 13, and we set this equal to x. We label our DAN and make it DNA. And we get x is equal to 13. I want you all to notice that these ln and e essentially just canceled out, and all we were left with was 13. ln and e are inverses of each other, and this is something that will happen every single time. And the next one, same as before, this is log base 10. So we make this log base 10 of 0.001, which we set equal to x, and then label our DAN to make DNA. We get 10 to the x is equal to 10 to the negative 3, which now x is equal to negative 3. So one major thing that we learned from this part of the notes is that ln and e are inverses of each other. ln and e are inverses. Now let's go on to graphing. So now let's talk about graphing logarithmic functions. To start off, we want to make sure that our log is first, because we can't do log or Dan has good DNA unless our log function is first. We know f of x is the same thing as y, so let's make these first changes. Log base 2 of x is equal to y. So in order to graph this, we're going to want to make this into an exponential. Let's make this DAN to turn into 2 to the y equals x, because that's DNA. This is probably one of the only functions that it's actually going to be easier to pick out y's and then find our x. So let's do that in our table. X, y. So some nice y's that we might want to use are -1, 0, 1, and 2. The x's that are going to go along with this are going to be 1/2, 1, 2, and 4. Now let's graph these. We have 1/2, -1, 1, 0, 2, 1, and 4, 2. We connect our dots and get something that looks like this. And there's our log function. It looks a little bit like half a hyperbola you could see that the domain is going to be x is greater than 0, or once we transform our function, it's going to be x is greater than h. Our range is going to be all real numbers, always. Our asymptote is x is equal to 0, or x is equal to h when we transform our function. Our end behavior, as x approaches infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches negative infinity. Our function is increasing everywhere. Decreasing, never. Our x-intercept, which is our zeros, is at 1, 0, which you can see here. Remember that our x-intercept is always when y is equal to 0. Our y-intercept, when x equals 0, is going to be none, because it's an asymptote. Our exact values are 1, 0, 2, 1, and 4, 2. Now let's look at an example of transformations. So we have f of x is equal to log base 1/3 of x. Remember, we want to make sure that our log is first before we turn this into an exponent. So this becomes log base 1/3 of x is equal to y, which we can now convert. Because this is our DNA. Now let's make our table. So since our base right here is a fraction, negative exponents are going to work out better for us. So let's start with 1, 0, -1, -2, and we'll plot these points here. When we put 1 in, we get 1/3. Put 0 in, we get 1. When we put -1 in, we get 3. When we put -2 in, we get 9. Now let's plot these points. 1/3, 1, 1, 0, 3, -1, 3, 4, 5, 6, 7, 8, 9, -2. And we're going to have something that looks like this. Our domain is x is greater than 0, our range is all reals, and our asymptote is x is equal to 0. Now let's do the next one. We put our log first. Log base 4 of x minus 1 equals y. And now we have to convert to 4 to the y equals x minus 1. We make our table. We're going to do -1, 0, 1, 2. We're choosing y values that are going to make this a nice number. We put -1 in for y. We get 1/4. But we can't just make this 1/4. Now we have to make it 1/4 is equal to x minus 1. So when we add 1 to both sides, we get x is equal to 5/4, which is about 1 1/4. We put 0 in for y, we get 1, so 1 is equal to x minus 1. We add 1 to both sides, and x is equal to 2. Now we put 1 in for our y, and we get 4. 4 is equal to x minus 1, which when we add 1 to both sides, we get 5. When we put 2 in for y, we get 16 plus 1 will be 17. Now let's plot these points. 2, 0, 3, 4, 5, 1, and 17, 2 will be way out there. So we're going to get something that looks like this. Our domain is x is greater than 1, our range is all reals, and our asymptote is x is equal to 1. Now let's look at the next one. Again, we need to put our log first. Log base 3 of x minus 2 is equal to y. Notice I put parentheses around this x. It's because this minus 2 is not being taken in by this log. Since this minus 2 is not going to be taken in by this log, we need to add it to the other side because it's with the y. To get log base 3 of x is equal to y plus 2. We change this into our Dan has good DNA form to get 3 to the y plus 2 is equal to x. We're going to start by making a table, again using our y's first. To make this equal -1, we're going to put -3 in. To make it equal 0, we put in -2. To make it equal 1, we're going to put -1 in. To make it equal 2, we're going to put 0 in. So these are going to be the values that are going to work out best for us. When we put -3 in for y, we get 1/3. When we put -2 in, we get 1. When we put -1 in, we get 3. When we put 0 in, we get 9. Now we can graph these points. And our graph is going to look something like this. Our domain is x is greater than 0, our range is all real numbers, and our asymptote is x is equal to 0. And now for our last graph. Just as before, we need to put log first. So log. So now we're going to talk about logarithm properties. So the first property we're going to talk about is the product property, which you see right here. If we have log base b of two things multiplied together, we can separate this log to be log base b of m plus log base b of n. So what we did was we separated our one log into two different logs when it's multiplication using addition. Now our quotient property. Similar, we're going to separate this, but now it's going to become log base b of m minus log base b of n. So again, we're separating one log into two logs, and now, since it's division, we're using subtraction. Our power property is what we're going to look at next, which now, if something is raised to a power, what we can do is take this power and bring it out front. So this would become n log base b of m. Now let's look at the first one, product property practice. Let's condense these two things together. So they both have the same log base, so what we can do is make this log base 2 of 7 times 4, which is log base 2 of 28. And that would be our final answer. Next one would be log base 25 times 4, which would be log of 100. Remember, when there's no base, we're assuming that it's base 10. You don't need to write that because it's assumed. Try the next one on your own. Pause the video here. This is what you should have gotten as your answer. Now let's do the next one. Expand using the product property. So what we can do is we know 6 is the same thing as 3 times 2, which we can now expand to be log of 3 plus log of 2. And that would be our final answer. The next one, we know 9 times 5 equals 45, so we can expand this, make this log base 7 of 9 times 5. You can choose any numbers that go into 45, as long as they multiply to get 45. And now we can expand this to be log base 7 of 9 plus log base 7 of 5. And this would be our final answer. Pause the video here and try the next one on your own. This is what you should have gotten as your final answer. Now let's go on to the next problems. Condense into a single logarithm. So now we're doing subtraction. So this could become log base 3 of 24 divided by 8, which we know 24 divided by 8 is 3, so log base 3 of 3. And log base 3 of 3, because these are both 3, this is going to be equal to 1, which is going to be your final answer. And now for this one, condensed is going to be log base 2 of 15 over 15, which becomes log base 2 of 1, which anything of 1, log base anything of 1 is going to be equal to 0. Try the next one on your own. Pause the video here. This is what you should have gotten as your answer. Now let's look at the next few problems. Expand using the quotient property. So we know 4 would be equal to, if we're trying to use the quotient property, we can make this 8 divided by 2, and again, we can use any values here. This would become log base 8 of 8 minus log base 8 of 2. As we said before, this is going to be equal to 1, so we get as our final answer 1 minus log base 8 of 2. Now let's try the next one. To expand this, this would be log base 5 of 1 minus log base 5 of 3. It already is giving us a division problem. We know anything log base anything of 1 is going to be 0. So then our final answer is just going to be negative log base 5 of 3. And I want you all to try the next one on your own. Pause the video here. This is what you should have gotten as your answer. Now let's try the last few. So this is going to represent the power property practice. So what we're going to do is we're going to bring this over here. We're going to make this log base 4 of 2 to the 5th, which we know is just log base 4 of 32. And that's going to be your final answer. This one, again, we bring here. This is going to become log base 2 of x to the 7th. Try the next one on your own. Pause the video here. This is what you should have gotten as your answer. And now for the last few. Expand using the power property. We can bring this out over here. This can become 7 log base 2 of 8, which we can break this down even more because we know 8 is equal to 2 to the 3rd, which now we can bring this to multiply with the 7, and we get 21 log base 2 of 2, which we know this will all be 1, and we're left with just 21 as our answer. This one is going to be 3 times x minus 1 log of 4, and that will be your final answer. Pause the video here and try the next one on your own. This is what you should have gotten as your answer. Please write any questions you have on this video on the bottom of your sheet, and we will talk about it the next time we meet as a class.